negative in front. If it's next to the equal sign like this guy is, then it's the x-axis. Okay? If it's negative, it's the x-axis after the equal sign. Here's an incident where it would be y. So you don't have to write this down, but just to show you. If it did this, negative x minus 1. Does that make sense? So this part right here in green, that would mean y. If there was a negative next to the x. If there's a negative next to the equal sign, that's when it's going to be reflecting over the x-axis. Okay? Awesome. That was new to you yesterday. It's the only part that was new, so that's really good that you asked that question. Then I'm going to have a horizontal shift that is this way. Again, that's left and right. I'm just kind of wondering. I just want to hear what you guys have to say. It is right for those that said it. If it's negative, it's always right.
If it's swapped inside the parentheses, it doesn't change if it's outside the parentheses.
You're right. I'm supposed to put right there. I'm supposed to put 1. So horizontal shift of 1 to the right. Here's why again. So for those that always question why this is the original form. X minus h. If I don't change signs, I'm positive I'm going right. If I'm changing signs, it has to be a negative number. In order to change a sign of something, it has to be negative. That's why it is the way it is. Now what about this negative 3? I am going down. Very good. Any questions on that? Now what does this 2 all the way out in front tell me it's going on? Very good. It's going to be stretching by a factor of 2. Questions? You guys are pretty good at that.
Well, if it's smaller than 1, it's going to be less.
Yep. 0.5, 1/2, 1/3. Okay. That would be compression. Okay. Any questions in general about anything right now? Excited for the 4-day weekend? I feel like that's driving a lot of people right now. It's driving me.
I thought it was Wednesday too. That is.
Next Thursday, you have an early release. Then you have Friday off, and you have Monday off.
I understand why you would get it.
Nope, it's next weekend.
I understand why there were 3 days because of Christmas, but where did the 4th day come from?
Because there's parent-teacher conferences, and there's parent-teacher conferences. So I'm going to be here till like 10 o'clock at night, so to have me teach the next day would be like brutal. So that's why they have it off. Does that make sense? Okay. Have your notes out. It's a pink packet, please. And there's Mickey on the front of this page because you all know I love Disney. Did you sign it? Okay, now take it. Anyone else have the signs? It was already due, but I will take it. Okay, if you have the lightest color hair, grab your pins. Who has the lightest color hair? What's between you two for sure? You need 4 different color highlighters today.
4?
If you don't have enough, that's okay. You'll have to switch with someone eventually.
First comes first.
4 different color highlighters today. If you don't have enough, it's okay.
3.
Yeah, you're supposed to be 3, but it's alright. It's okay.
I got 2. Jake probably took 3.
It's all good. If you don't have enough, it's okay. You'll have to switch with someone later on. That's fine. But you need 4. So grab the yellow, at least. Here you go. You need pink and orange. You need 4 different colors. Okay. I know. All right, I'm moving on. If you haven't grabbed your markers, you need to do that right now. 4 different colors. There's a reason for it. Trust me. A little faster. Okay, that's not what we're doing right now, right? Jake, you need 4 different colors.
4.
So you have 1 in your hand.
9.
I love juice boxes. I'm starting. Okay, it says power functions. We'll get you more if you don't have any. We have to switch a partner. It's okay because I didn't have enough to give out 4 for each. It's a big pink packet. We're on day 4 with Mickey Mouse. You have studied linear functions and quadratic. Now we're studying power functions or polynomial functions, which have different directions. A common type of polynomial function is a power function. So with your yellow highlighter, because all of you should have a yellow highlighter, I want you to highlight a common type of polynomial function is a power function. So common type. So for example, like x squared, x cubed, x to the 4th. There's no transformations going on. It's just x to the 4th or x cubed. A power function is a polynomial with a to the x to the n power. Again, we kind of already talked about that. For these purposes, we're really not going to talk about anything but besides if a is 1 and a is -1. We have Mickey Mouse over here telling us something very important that you're going to have to know for a couple chapters now. So this is a lesson where it's going to carry on. I always tell you that. I told you about yesterday and how transformations was going to carry on the whole entire year. Well, this is going to carry on as well. So end behavior is looking at the ends of the graph of a function. Look for or draw the arrows at the end.
Do yellow.
Yeah, just do yellow still. Because that's really not, this is just kind of like information. Again, end behavior, all it is, okay, so this is drawn out over here. The end behavior is where's it going? Where is the function going? If you're going into Math 098 or any other more advanced class than this, you're going to have to know this. It's why we do this curriculum, to prepare you for those higher classes that you're going to go into, even if you go to JJC. Or if you take Math 098 here at Lockport. So, here's what we're going to do. This is where you need the 4 different colors. The end behavior of a graph of a function is the behavior that as x is approaching something, where is a function going?
Right.
Oh, I just want to make sure that we're all doing the math part, right? Okay, so as x is going to positive infinity, take your yellow highlighter because I know all of you have it. As x is going to positive infinity right here. So that's what I want you to draw in. Okay, because I want you to see what I'm talking about. Like if I were to visualize right now in my head, as x is going to positive, this is x. It's getting bigger, 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 bigger. Remember when I wrote this out? That's kind of what we're talking about right now. So I want you to write that in as well. It helps me so much when I do that because then I know what I'm talking about. As x, we're on the x line, goes to infinity, the function for a cubic function, so pick a different color. If you have green, then use green. The function is going to positive. So again, if I asked you for the end behavior of a graph, all I'm asking you to do is tell me, hey, as x is getting bigger, so is my function. Now, what does that mean? Again, I'm trying to tell you, like, in real life what that would mean. If I'm like, hey, when I make a lot of money, okay, or over time, over years, like year 1, year 2, year 3, year 4, am I increasing my profit or not? It's kind of the same thing. So I'm asking myself, as the time goes on, am I making more money? Yes, because I'm going up to positive infinity. I'm increasing my profit all the time. However, obviously there's no negative time, but as x goes to negative infinity, that's the x value, so it's a different color. As x is going to negative infinity, obviously there's no such thing as negative time, so I can't really relate that to real life right now, but a way to read it. And then your last color, I'm going to use orange. The function is going to negative infinity. And you're looking at those arrows. So it makes you visually see what you're doing. I'm going to give you a second to make sure that you have all of that because this is like the first time you're seeing this, correct? You've never seen this before. Again, welcome to Math 3. Last chapter was still Math 2. Now we're on to Math 3. Okay, so as x is getting bigger, as time goes on, I am making more money. If I had a time machine, let's just say that. If I had a time machine and I were going back in time, I would be losing money. That's what you're reading when you're doing this graph. Okay, if I was a business person, I'd be like, hey, in time, do you think I'm going to be making a lot of profit from what I'm selling? Yeah, because if I look at my graph, it's going up. That's all I was asking. All right. Questions on that? Hopefully you have all of that all nice and organized for yourself. So now let's practice it. Here we go. Use the same colors that you just used to help you with your visuals. As x is going, I'm going to use mine the same color too. As x is going to positive infinity. That's the yellow. Right here, this bottom one. It's a different order. This is like the correct order I'll be asking you, so just keep that up. This is the yellow one right here. My color up here was green, so mine was green right here. So as x is going to positive infinity in yellow, there it is, going to positive infinity. Where is the function going? Up to infinity, positive infinity. That's all I'm asking you. Very good. So I'm going to write this out really quick. I'm going to do my negative infinity, my positive. Again, you don't have to write this. If you're someone that doesn't need this, that's okay. I just like to write it so that you can see what my brain is thinking. As x is getting bigger, over time, I'm making more and more money. Okay, that's what that means. Again, now here's if I had a time travel machine and I went back in time, going back in time. What's happening with my function though? It's going down to what infinity? Negative. That's it. So you're just describing where the arrows are going. That's all this is. Do you see how the arrows are going up? And this arrow is going down. That's all you're doing right now. Yes, the notation could be confusing. It could. But don't let it be. Okay?
Is that negative?
That is a negative infinity, yes. Okay. Again, it's just to help you visualize. If you want to give up the highlighters at this point, you can. I'm just having you see it with the highlighters. So this is going to help me out. As x is going to negative infinity in blue, where is the function going? It's going up to where?
To infinity.
To infinity. That's it. So if I had a time traveling machine, I'd be making money. I'm going up in profit.
So,
Yep.
So basically the answer will, so it doesn't really matter which way it's going, if it's going left or right. The only important thing is if it's going up or down.
Yep, for the arrows. But you need to make sure that you put it in the right order. So if I asked you, if I asked you this one first, as x is going to positive first, you would need to know that I'm on this side of the graph.
Okay.
Right? Because positive numbers are on the right side and negative numbers are on the left side. That's what this is saying. Yes, it's a weird notation, but that's just the math notation to describe it. If for some reason,
Wait,
yes, go ahead.
I was gonna say, how is that negative? How is that infinity if it's going that way? It's supposed to be negative infinity, right?
But we're only looking at the y values, so we see how it's going up forever. Up is positive. Yeah. So if I were to label it, this arrow is going up to positive. If it's going up, if the arrow's going up, it's positive. If it's going down, it's negative. What else was I going to say? I don't remember. I'll bring it back soon. As x is going to positive over here, where is the function also going? To positive infinity. Now, you're going to start seeing a pattern. What is this type of function called that we learned last chapter? A quadratic. What is this function that you learned maybe last year? Linear. Okay? So we're about to do a cubic now. This is what we just started talking about today, or get this chapter. So as x is going to negative infinity,
Negative infinity.
yes, it's going to be going to negative infinity in orange. Okay, and then as x is going to positive infinity,
Positive infinity.
it's going also to positive infinity. Very good. Okay, at this point, if you don't want to use highlighters, you don't have to. Okay, I'm just trying to show it to you. I am x, and I'm going towards negative. Again, if you want to think of it a different way, there's so many ways to think of this. All this is saying is, when you're on the left side of the graph, on the left side, am I going up or down? I'm going down, so it must be negative. This says if I am a positive number, because you're going towards infinity, you're on the right side of the graph. And it's going up, so I'm at infinity. Okay?
So
Mhm.
the answer is always going to be if it's going up or down.
Yes. Which is positive or negative. Now, I'm going to ask you a question. I wonder if I still have any. I'm getting more candy. Okay, you. Raise your hand and answer this. Does anyone notice a pattern between the degree of the function and the graph? What's a degree? Like x squared, x cubed, x to the fourth, the 3, the 2, and the 4, the degree. And what's the pattern that you're thinking of?
I'm seeing the pattern when it's negative infinity equals to negative infinity.
That's not always true, though. Not yet. We're going to get there somewhere else.
I see that the left side always goes up.
The left side,
The right side.
the right. Okay, so in these situations, yes, but that's not always going to be the case.
Negative five.
Negative and positive. What do you mean by that?
It's negative, and then it's positive, then it's negative, and then again positive.
For what degrees? What do you got over there?
Oh, I think it's you see how y equals x
Yep.
x2 and x4 are similar. I think that's the similarity right there.
Okay, so what I was trying to pull from you, and it's okay because this is really high order thinking. Again, this is not something that I'm demanding you to know, but you should be able to check your answers when you're doing these problems. If I am an odd degree, you see how this is a 3? You see how this is a 1? Because it's a linear. What's happening with my arrows? One's going up and one's going, and so they're opposite, right? So if I am an odd degree, 1, 3, odd, I'm going opposite, O and O. See that? Okay, this is a 3, it's going opposite directions. This is a 1, it's going opposite directions. But look, when I'm even, 2, they're going the same. That's always going to be the case. So if you're ever in a situation where you're asked about something, or if you want to check your answers, I will never have different infinities here when I have an even degree. I will have opposite infinities here when I have an odd degree. Odd, opposite. Okay, just trying to help you realize a pattern so when you're doing these problems, you can tell if you're going wrong or not. But I want you to give these a try. Go ahead and give these 3 a try for tickets. The arrows are going what direction? Up or down? So they're both? What infinity? Yeah, that's it. That's all it is. They're both positive. Yeah, positive infinity. Good. All right, here we go. Moving on. Maybe if I can find there it is. Okay, some of you are just getting stuck on like the little things. Okay, this is really easy. You just have to take a second. Look, they're both going up. So they're both positive. Like, I didn't even have to think. Like, I didn't even have to, do the process. If they're both going the same direction, don't even think. They're both going up. Boom, boom. However, this one is not both the same. So I have to actually figure it out. As x is going to negative, it's going to negative. And as x is going to positive, it's going to positive. Yes?
So one is the only exception for
Odd numbers, you're right, odd degrees.
Oh, I see how mine really work. Because like instead of it going like this,
Flip.
instead of going like this, it could go like this.
Yep.
It'd be opposite.
Yep.
I got 9 tickets.
Here we go. We gotta move on.
Well, now we have to sketch it.
Just like pretend to sketch it. Okay, we're not doing anything crazy. So here's the real test here. Raise your hand and tell me for tickets, more tickets. We get to raise your hand.
Whoa.
X to the 10th power. Is that going to be the same direction or opposite direction, Dalton? The same. So we're going to be going the same direction, like this. They're going both up. I don't care how you draw it. You can go like this. That's fine. They're going the same direction. You could go like, oop, it's okay, it happens. Worry about it later. It's okay, just worry about it later. You're fine. It could have went like this. Meow. As long as the arrows are the same, I don't care. It does not matter. You got. Oh, it fell on the ground. Okay. Now let's talk about odd.
Oh, no.
Down.
Go ahead.
It's like going.
It's going the opposite now. Here's the trick though. Is it gonna look, you said opposite, is it gonna look like this or is it gonna look like this? Because they're both opposite, but which one is it?
Other one.
Left.
What'd you say?
Your left.
It's
So
go, it's
Kinda
gonna,
like the former one.
is it gonna look like it's going down or is it gonna be looking like it's going up?
That one.
Yeah, it is that one, whoever
If
said
it's
that one.
positive, right?
Good, it's positive, so it's going to be going up. That's awesome. So let's talk about it.
Smart.
For 1 second. Odd, right? It's 13. So I know for a fact it's going to be opposite. I just don't know which way. If there's a negative out in front, it's going to be decreasing. If it's a positive in front, it's going to be increasing. So you see how this is like increasing? So it's positive, it's going up. Yes.
Does it matter if it's straight or like curved? No, right?
It does not. You could draw a straight line, but it's a 13th degree, so I really don't see how it could be a straight line, but it's okay.
So,
I wouldn't mark it wrong.
so what you're trying to tell me is that negative exponents are reflected.
Yep, so this negative one here, which we really didn't talk about here, it's odd and it's negative, so it will be reflecting. So that means it's going to look like it's decreasing because it's negative. It's negative, so it's decreasing. It makes sense.
Oh, okay, that's increasing. There's decreasing.
Yes. Yes. Now this one's negative. Here's a question. Raise your hand. Go ahead, Julianne.
It's going down.
It's going down. Very good. Is it going to be both going down?
Yeah.
Okay. Yep. You're good. So something like this. Again, I don't really care how you draw it. As long as the arrows are pointing down, I'm happy. It's pretty. People actually ended up liking this last year because it's once you get it, it's pretty straightforward. All right. Let's see if you can tell me the pattern. Here. Listen. We just talked about this pattern, like right above. If I have an even degree, and you don't have to circle, I'm just showing you, an even degree and it's positive. Even means what direction? Same or opposite?
Opposite.
Even degree?
Oh, no, it's the same.
It's the same. And if it's positive, it's going up, right?
Yeah.
So we're going to be at positive infinities. So there is something, if you were to memorize it, this is a chart that you would memorize. But you shouldn't have to memorize because you guys get it without the memorization. Yes?
So basically, the way to remember it is that even means both of them are the same.
Yes?
And odd means that only one of them is positive.
Only one of them is positive, yes. Okay, so odd and positive. As x is going to infinity here, we know that we're going to be also going up. And as x is going to negative infinity, we also know it's also going to be going. So here's a way to remember it. If it's a positive leading coefficient, which is the number all the way out in front, if it's going to the right, it's also going to be going up because that's just normal. The normal thing is for you to do the same thing. So like if I'm going to positive infinity for x, I should be going to positive infinity for y. That's only if we are going to be on the odd degree. So it's going to look something like this. But here's the difference, and it's what we just did above. Like if you were to look up, if you were to like scroll my little thing over here, or if you were to just look up. Now if we had a negative one here, you don't have to highlight, I was just showing you. What happened then to my infinity signs?
It's going to negative.
Yep, they're both going negative. So it's gonna look something like this.
Basically, what's happening here is that. it
You're flipping.
changes signs, that's it.
Yep. So then here, now we're gonna be decreasing. So it would be negative infinity and positive. So you just proved that to me above, and now we just wrote it down in a chart. We're almost there. Okay. This is gonna be fun and interesting for me. I'm excited. Now, let's see if you guys, how awesome you are, because I know you are all awesome.
Oh, wow.
Determine the function that matches the graph without a calculator. So let's just talk about A. What degree is A?
3.
Degree. Good. So it's going to be an odd degree, right? So does that mean we're going the same direction or opposite?
It's opposite.
Opposite. So right away I know it can't be these two. I'm already at a 50-50 shot. But one of them, remember this is a leading coefficient that's negative. Which one is it?
Number 1. I mean number 2.
Number 2, very good. So I'm going to put A here. So take a look. It's opposite directions. Because look, odd degree, opposite. But because it's negative, it's decreasing. Odd is opposite directions. And because it's negative, I'm decreasing. So can anyone tell me what number 4 is right away? Because there's only like one more option that's possible. C, very good. Wait, number 4?
It's actually B.
Isn't it B?
I think it's D.
I think it's B.
Everyone look one more time.
No, because
Number 4 is going opposite directions. Which one's the only one that else is going opposite directions? What letter?
C.
Oh,
D?
D. Look, right here. This is an odd degree. It can't be these two because they're even. Do these two and you'll get your homework.
And plus you have to use, plus you have to use the highest.
Do you know which one?
A, B, C.
This one's negative. Have a good one. Thank you. Listen, I need 2 more minutes of your time. I want to just do one with you. Look at number 1. It looks like this. Boom, 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 boom. It asks you what the degree is. All I'm asking, so this is how you know. All I'm asking, is this degree even or odd? So I'm going to put odd on that blank. Okay, that's easy. The leading coefficient, it's either going to be positive or negative. It's increasing, so it's positive. Okay, so you're not telling me the exact number. You're just telling me if it's even, odd, or positive. So as x is going to negative, where is the function going? So then the next one would be negative, and then the next